Okay, hi everybody. Next time I see you, we're gonna have a little quiz over 5-1 to 5-3. So we're gonna practice right now. So if you would get out a sheet of paper, or I don't care if you wanna do it in Notability, however you do it, we need to write down some problems and work through them. So the first problems on the sheet, and your quiz will not have this many problems on it. To tell the truth, I haven't written it yet, but the problems on the quiz will be like the ones that we're doing right now. All right, I put some extra practice in. All right, so cosine 32, cosine 10, minus sine 32, sine 10. Your job is to simplify that. And sine 47, cosine 11, minus sine 11, cosine 47. And tangent 15 minus tangent 9 over 1 plus tan 15, tan 9. So the first problems we're doing are just simplified. So you will have your colored sheet for this quiz. So it should be right there with you right now. And you should be looking on the colored sheet for this pattern. Cosine, cosine, minus sine, sine. Cosine, cosine, minus sine, sine. So that pattern is the cosine of an angle minus an angle. Plus an angle. That is the formula. Cosine, cosine, minus sine, sine is the formula for an angle plus an angle. Your angles are 32 and 10. So this is the formula for the cosine of 42. Done. That's all there is to it. So now this is the same thing. Find this pattern. Sine, cosine, minus sine, cosine. Well, that's a sine formula. And it's the formula for the sine of an angle minus an angle. So your angles are 47 and 11. So this is a formula for the sine of 36. That's all there is to it. Tan minus tan over 1 plus tan, tan. Well, that's a tangent formula. And it's the formula for the tangent of an angle minus an angle. So your angles are 15 and 9. So this is a formula for the tangent of 6. So you will have a problem or two, just like that, where you'll look on your sheet till you find the pattern that's represented. You got to figure out if it's a cosine, sine, or tangent. Then you got to figure out if the angles are being added or subtracted, and then you just add them or subtract them. And that's all there is to it. Pretty darn easy. All right, let's see what's next. Next, we're going to do a problem like find the tangent of 75 degrees. Now, I know yesterday we were doing half angles. This is not a half angle. The half angles aren't on the quiz. If you wanted to do it that way, it wouldn't be wrong. But my intent, which again, you can do a half angle if you want, but my intent is for you to think of 75 as maybe 45 plus 30. And now we have a tangent of two angles added together. So this is like your U and your V. So that says tangent of the first plus tangent of the second over 1 minus tangent of the first, tangent of the second. That is the formula for the tangent of an angle plus an angle. Okay? So now I'm going to plug in those values. I'm going to plug in whatever the tangent of 45 is, so over here to the side. If I have it memorized, that's great. The tangent of 45 is 1. Opposite over adjacent, 1. So I'm going to put a 1 in here. I got to figure out that. And then in the bottom it's going to be 1 minus 1 times whatever. So I still need to fill in the tangent of 30. Tangent of 45, I put in 1s. Tangent of 30, I have to figure out. So maybe I know that. Maybe I have that memorized. Maybe I don't. The tangent of 30, is 1 over root 3 or root 3 over 3. So that's the number I'm going to put in here. So I figured out what made 75. I figured out what formula I was going to use. And then I plugged in the values in the formula. So what I have is 1 minus root 3 over 3 over, oh, excuse me, that's 1 plus, that's a plus. 1 plus root 3 over 3 over 1 minus root 3 over 3. That is a very ugly thing. So we are not allowed to have little fractions inside big fractions. So I'm going to multiply every term by 3. That'll give me 3 plus root 3 over 3 minus root 3. That looks a lot better. But I'm not allowed to have a radical in the denominator. So now I'm going to multiply by 3 plus root 3, the conjugate of the bottom. So now I'll FOIL 9 plus 6 root 3 plus 3. Outside is 3 root 3. Inside is 3 root 3. That makes 6 root 3. And then root 3 times root 3 is 3. Over 9. Outside and inside cancel, and minus 3. Again, radical 3 times radical 3 is just 3. So I've got 12 plus 6 root 3 over 6, which everything there is divisible by 6. So my final answer is 2 plus root 3. Good. Let's do another one like that. Let's do sine 285. So I'm going to go through exactly the same procedure. It's actually going to be a little easier. Sine 285. So we've got to think about 285 as being two angles added together, like we just did 45 plus 30, or subtracted. Doesn't make any difference. You can add or subtract. But the angles have to be special. So I think I told you this before. If not, I'm telling you now. Whenever my angle that I'm working with has a 5, ends in a 5, then I'm thinking 45. So if I think of 45, this would be 45 plus 240. And before you panic, I want you to think about what 240 looks like. 240 degrees. 240 is a 60-degree angle, a 60-degree reference angle down in quadrant 3. That's special. So negative root 3 and negative 1 and 2. There's your triangle for 240 degrees. Okay, and my 45, I'll go ahead and draw my 45 again. I already drew it once. Okay, so here we go. The formula for the sine of an angle plus an angle is sine of the first, cosine of the second, plus cosine of the first, sine of the second. Okay, so here we go. I gotta plug in all these values now. I've already drawn my picture, so I'm a little ahead of the game. Sine 45 is 1 over root 2, which I'm gonna go ahead and rationalize right now, root 2 over 2. Cosine 240 is negative 1/2. Cosine 45 is root 2 over 2. And sine 240 is negative root 3 over 2. Now, these are being multiplied, so I can multiply them, and that'll be negative root 2 over 4. These are being multiplied, so that's negative root 6 over 4. 2 times 3, under the radical, root 6. And then those have the same denominator, so I can write it as one fraction. I cannot combine the radical 2 and the radical 6. They do not combine. They're not like terms. But I can write it as one fraction instead of 2. And there it is. There's the sine of 285. Okay? Just 2 more kinds of problems on this quiz. 2 more kinds. The next one is one of the ones kind of gives you fits sometimes. A verify. You are going to have to do one verification on this quiz. So they're all different. All we can do is practice, so we'll practice a couple here. I did give you a packet with some extras in it. Feel free to practice the extras if you want. What I've got written down here to practice is tangent squared minus sine squared equals sine squared times tangent squared. And the directions say verify. Okay, verify. That means show that it is true. Okay. What I would do, and again, it's your choice, you're the one sitting there doing the problem, but what I would do is over here, I would change this into sine squared over cosine squared. You should know that by now, but again, you will have your colored sheet, so you're not like totally on your own. Minus sine squared over 1. Now I have 2 fractions now. Since I changed this, I now have 2 fractions being subtracted. So I'm going to get a common denominator. And my common denominator is going to be cosine squared. So this one needs to be multiplied by cosine squared over cosine squared. Now, gang, that's times there. Now they have the same denominator. So I can put them together in one fraction. So my denominator is cosine squared, and the numerator is sine squared minus sine squared cosine squared. Now at this point you're thinking, Mrs. Ford, this is getting worse, not better, but oh no, you're almost there. Look at that numerator. Just like the equations that we were doing yesterday, you can factor that numerator. So out will come a sine squared and out of the numerator, and that will leave me with 1 minus cosine squared. wait a second. What is 1 minus cosine squared? What is this? That's something. Look at your paper, or you should actually know this by heart. What is 1 minus cosine squared? It's sine squared. So what I have now is sine squared times sine squared over cosine squared. Now your gut wants you to multiply those two signs together and get sine to the fourth. I don't. I need squares. So I'm going to go ahead and I'm going to split this. I'm going to rewrite that as sine squared over 1 times sine squared over cosine squared. Now please don't get all confused. If I multiply these together, isn't this what I get? Isn't this what I get when I multiply top times top and bottom times bottom? Yes. And this right here is tangent squared. So now I have my sine squared times my tangent squared. This is 4, there's no way I can do that by myself. Yeah, I think there is, but you can at least do some of it. So whatever you do, take your problem, whatever problem you have, take it as far as you can. Let's practice another one. Let's do it again. Like I said, I haven't written the quiz yet, but I think what I'll do is give you a couple of these and you will pick one. That'll give you a little bit of choice in case there's one that you feel like you can do. All right, let's try this one. Tan x plus cosine x over 1 plus sine equals secant. I know your gut feeling might be, let's just jump right in and get a common denominator. I think I won't do that just yet. I think the first thing that it kind of makes sense to do is to change my tangent into sine over cosine. Now I think I'll get a common denominator. So here's what you need to stop and think about. The common denominator has to have a cosine and a 1 plus sine. That's going to be your common denominator. So this one is going to get multiplied by 1 plus sine. And this one is going to get multiplied by cosine. Now, both fractions have the same denominator. And that denominator is cosine 1 plus sine. That's my common denominator. Now, what are my numerators? Well, this numerator is sine times 1 plus sine. And this one is cosine squared. Cosine times cosine. Well, I think I'll go ahead and distribute here. Now, please do not even think about canceling. Because of that add, you can't do that. You cannot cancel unless you can cancel the whole shebang. Okay? So don't. Instead, distribute. Excuse me. So sine plus sine squared plus cosine squared all over cosine 1 plus sine. So I distributed here. Now you should be getting all excited now Because what's this right here? That's 1. So we have sine plus 1 over cosine times 1 plus sine. Well, wait a minute. Now, kids, you can cancel. Because remember what I said? You have to be able to cancel the whole thing. And you are. You're canceling the whole thing. Not just part of it. Not just part of it. You're canceling the whole thing. So what am I left with? 1 over cosine, which, oh my gosh, 1 over cosine is secant. Let's review the steps there, because I don't think the steps there are hard. You can do this. Change tangent into sine over cosine. Get a common denominator. Notice sine squared plus cosine squared is 1. Cancel, and you're done. So you have one of those on your test, or quiz, one of those on your quiz. All right, now we're going to solve a couple of equations, and we actually were doing that in class last time. So this should be not too bad for you. Solve a couple of equations. We'll start with this one. 2 cosine sine minus cosine equals 0. And the directions say this. So we're doing it in degrees. And we're doing this whole quiz without a calculator. Okay, so who remembers what we need to do first? We just did it in our last class. We're going to factor out a cosine. Now, in some of the problems we looked at before, first thing we had to do was move some stuff because we needed a 0. We already got a 0. So now we're going to factor out a cosine. And when I factor out a cosine, now I have 2 factors, and I can set them both equal to 0. This looks an awful lot like one we did earlier today. Anyway, zeros. Zeros are always part of your unit circle. Cosine is which variable? Cosine is x. And x is 0 here and here. So your answers to that are 90 and 270. Top and bottom, 90 and 270. This one says the sine equals 1/2. Well, sine is y, and y is positive numbers up here. And sine is opposite over hypotenuse, so that makes this angle right here 30, because sine is opposite over hypotenuse. And this one's also 30. So our answers are 30 and this angle, which is 180 minus 30, or 150. So there are the answers to that problem. Okay, one more. We'll practice one more. 2 sine squared minus 5 sine minus 3 equals 0. Oh golly. Again, We have the 0 already, so we don't need to worry about rearranging anything. We have our 0. In the last problem we did, we factored out a cosine. You are not able to factor anything in this problem, guys. See this 3 out here? There's nothing, you can't take out a sine because he doesn't have one. Instead, you got to stand back and look at this like a quadratic equation. This factors into 2 binomials. It's like unfoiling it. So we'll have 2 sine and 1 sine. Think about foiling. This times this would give you 2 sine squared. And then at the end I have a 3. So I need a 3 and a 1. And I need one of them to be negative and one of them to be positive, because boys and girls, when you FOIL this, that's the only way you're going to get -3, is if one is positive and one is negative. Now, I have no idea if I have the right factoring, so I'm going to check it. First times first. Outsides. Insides. And last. Now, this and this look great. The middle does not look so good because those do not add up to -5. So I have not factored correctly. Now I believe I have used the right numbers, but I think I have them in the wrong spots. So I'm going to put the 1 here and the 3 here. Now that won't change the first term, still 2 sine squared, first times first. And the last is still going to be -3, so that's good. Now what's in the middle? Outsides give me +6. Insides give me -1. Now I am getting closer. This gives me a +5, and I need a -5. So I'm going to switch these 2 signs. That will make this a negative and this a positive, and now I have my -5. So here are the factors. Now we're not done. Now we have to set those factors equal to 0. So 2 sine plus 1 equals 0, and sine minus 3 equals 0. All right, so that first one says that sine x equals -1/2. Okay, so sine is y, and y is negative down here. If opposite over hypotenuse is 1/2, then this angle right here must be a 30. And so is this one. Now, my answers, though, are not 30. 30 is not an answer. This angle is an answer. So what is that angle? 180 plus 30, which is 210. And then 360 minus 30, which is 330. So there are the answers. Those are degrees, of course. There are the answers to the first factor. All right, now let's look at the second one. The second one says sine x equals 3. Now wait a minute. Sine is y is positive up here. But that says opposite is 3 and hypotenuse is 1. You guys, is that possible? Can I have the hypotenuse being shorter than this side over here? No. That's extraneous. Sine and cosine never are more than 1 or less than -1. Sine and cosine, think of that way, they're sandwiched between 1 and -1. So it is impossible for the sine to be 3. Therefore, these are the only answers to the problem. All right, so next time I see you, you're going to have a quiz, and it's going to have those 4 kinds of problems on it. We've done 4 kinds of problems on this practice quiz. And you can redo these problems. You can go to that practice packet I gave you and find some similar ones to work on. Completely up to you. But that's the quiz. Okay. I posted information about your spring paper, and in Schoology I posted. It's pretty detailed. I don't think there's anything that you have questions about. If there are, certainly you can ask. I do want you to understand, though, that your paper is about what you are doing during Lent to somehow, even in the tiniest of ways, improve the life of someone else. And when you write your paper, you're going to reflect on the impact that choice, that promise, had on you and the impact it had on the other person. The paper must be submitted in hard copy. April 13th, 3:15 p.m. is the deadline. It must be turned in to turnitin.com, just like always. It's got a minimum of a page in length, typed, double space, MLA format, all the same regulations as before. But this time, you're not writing about yourself. You're writing about the impact of your Lenten promise on you and on the other person. So some examples, real quick. Some examples might be, you have a little brother, and of course he idolizes you, and you don't have time to mess around with him very much. So let's say you decide that every Saturday at 10 a.m. you're going to go outside, or you're going to do something with your brother. You're going to go throw a football with him, or you're going to play a video game with him, or you're going to help him with his math homework. Whatever it is, you're going to set aside time every single week, at least once a week during Lent, to spend time with your brother. Or let's say you have an elderly grandparent who lives alone, can't get out very much. Every Sunday afternoon, you decide to go spend a couple hours with grandma. Perfect. Whatever promise you decide on, and it can be as simple as washing dishes. It can be, I'm going to fold the laundry once a week or something. It can be a tiny little thing, but it has to be something that you do over and over and over. It can't be a one-time deal. And therefore, you cannot write this paper. You cannot begin writing this paper for at least another month, because you have to choose a promise and then live it and then write about it. Okay? If you have any questions about that, please feel free to reach out to me. Okay? And I'll help you understand what the expectations are. All right. Well, I had planned to do some notes, but this video is getting kind of long, so I think I'm just going to do one more problem from our notes, and that's it. And so this is a 5.4 3C. So I'm going to do 5.43c, which will finish that section of the notes. And the problem is cosine squared plus cosine equals cosine 2x. It's an equation, and it's got the same directions as your quiz has. We're going to solve this. Now, this exact equation will not be on your quiz because your quiz does not have any 2x's. There's no double angles on your quiz. But you need to change that 2x into something that's on your sheet. This one has 3 versions. You can pick. There's a version that has cosines and sines. There's a version that has only sines and a version that has only cosines. I'm going to choose the version of this formula that has only cosines because that's all I've got in the rest of the problem. So that version is 2 cosine squared minus 1. One of the formulas for cosine 2x is 2 cosine squared minus 1. All right? So now I'm going to move everything to one side and get a 0. So I'm going to bring it all over this way. Okay? So I'm going to subtract cosine squared. So that's going to leave me with 1 cosine squared. I'm going to subtract cosine and minus 1. Now, this is a tough problem. At this point on your quiz, you would factor that. You would set up 2 parentheses and factor it. This one does not factor. What do I do, guys, when I have a quadratic that doesn't factor? What do I have to do? Use the quadratic formula. So A is 1, B is -1, and C is -1. I'm going to use the quadratic formula. And whereas normally I would say x equals -b, blah, 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 now it's cosine x equals. That's my variable, cosine x. So cosine x equals -b plus or minus the square root of b squared minus 4ac all over 2a. You need to be able to do a problem like this, but not on the quiz. This is not going to happen on the quiz. You might get an equation that looks like this on the quiz, but it will factor. You'll be able to factor it like the one we did in the practice. This one doesn't factor, so I'm doing my quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So cosine x equals 1 plus or minus the square root of 5 over 2. All right, now you guys listen. That is 2 answers. That means that cosine x equals 1 plus root 5 over 2, or cosine x equals 1 minus root 5 over 2. All right, let's see what those numbers are. 1 plus the square root of 5 divided by 2, cosine x equals 1.618. Stop right there. We just talked about it. Cosines and sines can never be bigger than 1. It is impossible. If you did second cosine, 1.618, it would say error. So go ahead, do it. It says error. There's no answers that are going to come from that one. Now what about this one? 1 minus the square root of 5 divided by 2. Now that one is negative 0.618. So you are saying that the cosine is a negative number. Now, where is the cosine a negative number? Cosine is x. X is negative over here. So I want you to second cosine 0.618. Notice I dropped the negative because I've already taken care of it. I put it in these quadrants. Negative's done. I need to know the size of that angle right there. And I don't want a negative angle. I want a little tiny angle there. So second cosine 0.618 gives me 51.83. That is the angle that has a cosine of 0.618. So what are the answers? Well, one answer is this one, which is 180 minus 51.83. And one answer is this one, which is 180 plus 51.83. So the two answers to the problem are 180 plus 51.83, 231.83, and 180 minus 51.83, 128.17. That's a tough problem. That's a toughie. Had to do lots of weird stuff with that. But you did a great job. Quiz next time. I see you, and we will continue with our note taking. And we'll be having a test pretty soon. Have a great day.